Hi there. I'm happy to welcome you in email RIPA session where we discuss reproducibility, experiment, and pipeline automation for machine learning. I'm happy to be a part of this discussion, and today I'm going to share my thoughts on how to set up your model monitoring. First of all, let's meet. My name is Emeli Dral, and I'm CTO and co-founder at Evidently AI. Prior to it, I co-founded an AI industrial startup and served as a chief data scientist at Yandex Data Factory. You might also know me from the popular machine learning course on Coursera platform. So during my work in Yandex, I worked with a lot of AI-based solutions in many industries, right, from banking to communication to manufacturing. So my today's talk will be based on the experience I gained during that time. It's well known that machine learning solution development starts from the problem statement definition and data preprocessing and preparation, right? So after this, we move to a bunch of experiments when we try different feature engineering, different algorithms and its compositions, and come up with the final model. After it, we need to move our model into production, and this is the phase with what we still sometimes struggle because there is a limited experience in the industry on how to do it, and this is kind of more engineering than a data science task. Anyway, after we moved our model into production, we need to keep an eye on its quality because at least due to the nature of the technology, we know that our machine learning model can degrade significantly. But if we have some production service, we need to ensure the expected level of quality. And this is why we come up with some monitoring, because this is kind of a link between our production models and the experiment phase. If something went wrong with our model in production, then we need to first figure out what is wrong, right? And if, for example, this is some data drift or roles change too fast, we need to move back to our experiment phase and maybe retrain our model on the new fresh data set, or even conduct a bunch of new experiments to come up with the entirely new machine learning model. So the monitoring is the link between our productions and experiments. One might say, okay, but you have production services for decades, so monitoring is already solved issue. Yes, I agree, there is some truth to it, but I would say that for machine learning models, the data creates the extra layer of complexity. Of course, as machine learning service is still production service, we need to measure standard service health metrics. I mean, uptime, memory usage, latency, and many more. But together with all these metrics, we need to make sure that we fit into our model the good data. I mean, the relevant data, the data with good quality, with no missing values and many stuff. So we need to make sure that we actually able to get data from many data sources we might use, that our pipelines work correctly, and that route does not change so much, right? So, and here the comprehensive monitoring of data health and model health comes. And now I want to share with you a very interesting study. This report was published by FICA company, which is very famous for its FICA score. And they figured out that 67% of senior analyst leaders do not monitor their models after they went to production. And I would say this is kind of shocking because, be careful, there are a lot of production services that are not monitored. And I believe there are some reasons for it. And first of all, set up comprehensive monitoring from scratch is a complicated task that needs a lot of resources. So it's not the thing that you can do like in a couple of days. And the second reason is that sometimes we start monitoring things only after first huge breakage happened, right? And sometimes the monitoring seems to be optional or just an afterthought. And due to the complexity of the task itself, so create the monitoring from scratch is kind of huge. Especially where we have limited resources, I want to be pragmatic here and suggest you the step-by-step approach for setting up such monitoring. The idea is to start monitor your model as soon as possible to get this stable production. And in each stage, we will cover more potential risks and make our monitoring more and more reliable. So before we actually discuss the steps to create the comprehensive monitoring, I want to discuss some factors that might influence the decision what to monitor and how important it is for our case. And the first factor I want to discuss is use case importance. And here, of course, we mean the economic value we gain out of our machine learning service. For example, we can create some recommender service that recommends movie to our users, or we can create some credit scoring system. And of course, out of the system, we gain a lot of value to the company, right? And more value we gain, the more attention we need to pay to the service. But sometimes, our machine learning services doesn't bring us a lot of value when it works stable, but when something went wrong, our risks or costs of errors can be really, really big. For example, if we created some machine learning recommender system that recommends some parameters for manufacturing, and we give the wrong parameters, then we can create a lot of broken products, right? And this is the huge consequences. Or even, I mean, if our model works in some healthcare or social services, the consequences might be even much painful. So this is a very important thing to consider, not only economic value, but the consequences and risks. The second factor is the solution complexity. We might use only one database, and it's much easier than, for example, usage of many different data sources which are stored in different systems. Our pipelines can be pretty complex, and we need to make sure that each pipeline works correctly. The scenario in which we use our model can also differ, and the batch scenario is sometimes much simpler than real time, because when we work in a batch scenario, sometimes we even might have some delays between the moment we actually generated some output of our model, I mean predictions or recommendations, and the moment we actually start use this output. Let's take as an example the marketing campaign optimization, where our model can recommend the optimal channel of communication with a client and the best suitable offer. We can generate these recommendations by our model, then take a look at them, analyze, make sure that everything is okay, and only after that start sending letters or start calling, right? So, and this delay might be very useful to make sure that everything works correctly. And for real time, it's not the case, because in real time, of course, we do not have any time to do some checking or testing. And the last but not least factor is the team resources. Of course, if you work in a big IT company, probably you will have the specific department or at least team who could help you with setting up the comprehensive monitoring, and it makes it much easier. But if you are working in a smaller company and you just small IT department, or even you are a startup, then probably you have very limited resources for the development in the first place. And of course, for monitoring, you have even less. So considering all these three group of factors, use case importance, complexity, and team resources, let's try to create the step-by-step approach for our machine learning monitoring. It will help us to start monitor important things earlier, while we'll still continue implementing the monitoring system itself. Before we go into the details of what metrics we need to monitor, I would like to briefly discuss the infrastructure for monitoring. Here I assume that you already have some production services, so machine learning model will not be first thing you put into production. But okay, if it's the case, then I recommend you to pay much more attention in the to the model, not just model, to the monitoring infrastructure itself. Okay, so then I think it should be your bigger focus. But if the machine learning service is not first thing you are about to monitor, then probably you already have some infrastructure and tools that you use for monitoring of your other systems. For example, and can be Prometheus database for storing your events, and Grafana for calculating the metrics, aggregating data, and perform visualization. I personally like this toolset, Prometheus and Grafana, but you can use other database, for example, to store your logs, or other system to make the report and visualization and create alerts, right? So this is totally up to you. I have a lot of very nice tools in open source and from different vendors. The only thing I want to say here is do not hesitate to use the same tool kit that you use for other services. Okay, so there is no need to add something specific for your machine learning services, but you might still need to add some extra data to your database, because you might need something to calculate the quality metrics, for example, for your machine learning models. Or sometimes you will also need to start logging more, because, right, it's a new service and probably you'll need to log more data to monitor it further. And yes, on the monitoring tool, you might need to calculate more metrics. So you will need to add this formulas and functions to calculate your metrics explicitly in the service you use. Okay, but in most cases this is comparably simple, and if you already set it up the monitoring for other services, then you can create something very similar to your machine learning. And in other cases, you could have the BI systems, for example, Tableau or Looker, which are pretty famous, or you might even have something custom developed in your company, for example, using these absolutely beautiful libraries like Matplotlib, Plotly, or something which works for other programming languages. This is very nice because such system is usually very flexible, easy to use, so you can perform the deep analysis or debugging, but which works very well in a batch mode when you have some time delay between the model produces some output. This delay you could use to generate your report and actually analyze that, and then make use of your model's output. This doesn't really work for real time, okay? So I really recommend you to have both monitoring and BI systems, because even if you have monitoring, this good, but when you get some alert and you need to figure out what is happening, it's very handy to go to your BI system and start analyzing and tweaking the data to make to get better understanding of what is happening. So this is the good combination of tools to have. And again, for machine learning, you can use same dashboarding system or report system that you already use for your other data. Okay, so that's pretty much all I wanted to mention about infrastructure. And now we can move to our metrics that we need to calculate for monitoring. And before we discuss it, I want to bring some examples. So I used the regression use case, and this is bike demand prediction. So I used the publicly available dataset. If you are interested, you can go to Compl, for example, and download this dataset to play around with it yourself. For example, create some fancy plots or train some models and calculate its quality. And I like this dataset because this is a regression. And it's very intuitive. So we have a lot of data about seasons, about weather, about holiday, and based on this data, we need to predict how much bags will be taken into rent during each hour. Okay, so I trained model before, and all the plots I will be showing you later will be created based on this dataset. And first stage of monitoring I want to bring up here is the service health, because first of all, we need to figure out, does our service actually work? So here, again, I assume that you already have some production services, and I suggest you use the same system and the same approach for your machine learning service, right? And just only one thing I want to bring your attention to is the model calls dashboard. I suggest you to create this, because even if your service for which you use your machine learning works correctly, it can happen, but your machine learning model will still be out of usage. So make sure that someone actually uses your model, so your model gets some responses and the answer. And for doing this, I suggest you create the model calls dashboard. Okay, let's say we made sure that our model works. And the second question we have is how well actually it works, right? So how it performs and did anything break? And for doing this, I suggest us create the model performance monitoring. And model performance is something we are pretty comfortable with during the experiment stage, because for experiments we have our target function calculated, and we get our predictions, and we can easily compare it with the target and calculate the bunch of quality metrics like accuracy score, error scores, and many other things. But when it comes to production, we do not always have the immediate feedback loop. I mean, sometimes we work with some pretty convenient cases, for example, the demand predictions, where we predict the demand for our products or services, for example, for the next hour. And in this case, it's pretty comfortable because we can just wait for this hour and directly calculate the error rate, for example, right? So this is something with what all the data scientists are pretty comfortable. But when, for example, we came very same case, demand prediction, but with longer horizon, like a week or a month, then it's not that easy, right? Because, well, for doing them, we need to wait for this week or month to get some feedback and calculate quality metrics. And this is, unfortunately, what many of us still do. And here I also have some pragmatic recommendations for you. First of all, model output itself is a very useful thing, because analyzing your model output, you could already come up with some conclusions and understanding of what is happening. Let's say when you have your model output and you look at it, you already had in mind some expectations of what you actually want to see, right? Because these expectations can be get out of the domain knowledge or use case scenario or your business understanding. For example, if we're working on demand prediction, then we expect to have positive values only, right? At least non-negative. If we are working on probabilistic classification tasks, then we expect our probabilities be between the 0 and 1, right? Or we might expect our outputs to have the specific distribution, for example, with known mean value, right? So, and all these things we can check having our model output without any feedback. So I really recommend you to analyze your model's output, and before start analyze, come up with some expectations which you will be checking later, okay? So this is first and very basic stuff. If you have more time and you still have your data from an experiment phase, and this is the recommendation to actually save it, okay? So if you have the data from the holdout testing, for example, then you can easily compare your distribution from the holdout test with your distribution from the production. And this is very handy, because if they are similar, then probably you can say that everything is more or less okay, right? But if it's different, it's very important for you to make sure you understand what are the reasons for this difference. And if you understand these reasons, for example, it can be due to seasonality or due to expanded audience or something like this, then it's more or less okay, right? At least it's something you know reasons for. But if there is no obvious reasons, but your distributions are differ significantly, then it might be a signal for you to dig deeper and to understand what's actually going on. Okay, finally, if you have your ground truth, then of course calculate some quality metrics. it's again good to have some benchmark, for example, the quality that you got on your holdout test, and compare your production quality with this benchmark. And when it comes to quality metrics, this is the good question, which metric actually we should choose, because, well, we have a bunch of metrics, and different metrics suits better for different cases and different situations, right? And for example, if you work with the unbalanced classification problem and you choose the accuracy score, you might start having a problem with your minor class, but accuracy level is still pretty high, and you could miss the moment when your model started degrading, right? So it's really nice to be careful when you choose the right quality metric. Or for regression, you could, for example, use root mean squared error, but the mean absolute error or mean error is much more intuitive, so sometimes it's more convenient to have some straightforward metric which you see and immediately understand what is going on, right? And one more recommendation here is, at least from time to time, analyze your error distribution, because the error distribution helps you to see what is happening with your model from a larger perspective, right? So, for example, you can check if your error is still symmetric to 0, or your model starts underestimating or overestimating your target function. So it's good to have this distribution, and from time to time check that everything works correctly. One more thing, just say it again, there is no silver bullet between the metrics, and for different use cases, it's better to choose the very suitable metric. And here, for example, I use the mean percentage error, right? So this is the distribution of percentage errors on these data sets, and looking at this metric, you can see that we have some objects with pretty huge error, right? Like wow, that's a lot, minus 400. So having this metric, we can go and check what is happening with our objects, right? So this is pretty handy, and you can get this information straightforward. This is why the choice of metric is something that you need to invest your resources in. And last but not least thing I want to bring up here is the business metric. During the work of project, we work with a huge team, right? So there is not only data scientists and analysts, we also have some system engineers and some business users like product or project managers. And they are also very interested in keeping our model into expected range of quality, right? And here I suggest you to invest some resources into understanding on how the quality of your model connected with the business value of your service, and come up some metrics that describe this dependency. I mean, for example, sit together with your manager and discuss actually what he or she expects to have out of your model. And for example, you could figure out that it's good to keep your error rate or just error lower than 100 bytes in our case, like, right? So, and in this case, you can calculate the share of errors that are higher than this threshold and publish this dartboard for all your team. And this will be very nice of you, because you will keep all the team informed, and your manager will not need to like create the Jira task for you to check if everything is okay with your model, which is quite embarrassing, right? So it's good to keep all the team informed and publish some dashboards. Okay. Let's say we pretty much covered the model performance, and if we see that model performance is good and all your quality metrics are high or low if it's here, then you can still go and do your other tasks, right? But if something dropped, then we need to figure out where it breaks, what has happened, and where to dig further. And this, I suggest you to go for data quality and data integrity, because data is one of the most vulnerable part of our machine learning service, right? And we need to keep an eye on our data in the first place. So here there are a lot of different statistics we can calculate, and I suggest us start from the missing data because this is pretty straightforward and simple to calculate, and it's already cover a lot of issue. And when it comes to estimating the amount of missing data, we can do it really in different ways. For example, we can aggregate the information about missing values for all features and have only aggregated value. Or we can really track it per feature, but for larger data sets, it's not that convenient. But in this case, I suggest to use your knowledge about feature importances and monitor it feature-wise only for key drivers. This is the factors which influences your model more than others, right? And it will be pretty handy to make sure that everything is okay with these features. And missing value is not the only statistics we are interested in, because together with it, for example, we can check that types of our features match with our expectations, and all our features lay inside of the expected range. And this range, we can, the expectations on the feature range we can get from our business understanding or understanding on the domain area. For example, if we have some features related to temperature, we can say, okay, we know that temperatures usually is below -30, okay, -40 and +30 Celsius, right? So then let's keep it like this. Or if we talk about some user's age, we can say, okay, generally age can be from 0 to like 110, let's stay positive, or 130, let's stay even more positive. But for your service, you expect to have someone like from 18 to 55. So you can create some different ranges depending on the problem you are working on. But range violations is pretty rare case, I would say, and sometimes you could still have your feature in the expected ranges, but it could be already broken, unfortunately. Let me put an example for you here. Let's say we have some temperature sensor which we use for our predicted maintenance problem. You already got that I really like this example from manufacturing. Sorry for it. And you see that your temperature sensor is inside of the range, but it always gives you 0 Celsius value. So if you have monitor only range violations, you wouldn't get any alert because 0 is inside of your ranges. Let's say your ranges is from 0 to 100, okay? So, but if this sensor has, if the data from the sensor has the significant value from model, I mean, if it's an important feature, then probably your model will get confused by having this constant value. And for being able to catch things like this, we need to perform much more complicated analysis. I mean, we need to analyze feature distributions, the individual one, and for important features, we need to analyze multivariate distributions for some important subsets of features. And this is pretty time consuming to implement it and to actually go through it and making sure that everything is okay. But luckily here, I also have a pragmatic approach for you that will not cover like all the potential problems, but which has a solid chance to catch some problems if you actually have one. And here I want to tell you about the correlations. The idea is that if your feature changes its nature, or for example, breaks or start behave in another way, then probably the linear dependency between this feature and other features changes. Of course, I understand, and I know that you all are also understand that correlations only cover linear dependencies, but if your feature has changed a lot, then probably you will see it in some linear dependencies with other features. No guarantee, unfortunately, but really solid chance. And let's discuss how can we do it actually, because for this you will need to have our reference data set. And by reference here, I mean, for example, data set from training phase. And what you can do is to calculate the correlations matrix from the training stage And then after your model went to production, wait for some time and again calculate correlations between your features into production. And finally, you need to compare these correlations to see if there is any significant changes here. And this is what I did in this example. And you can easily, okay, not that easily, but you can see that the correlation between months and temperature and feels like temperature was positive during the training, and it gets negative during the production. And this is exactly the signals we want to catch from this correlation analysis. And if we dig deeper, we will easily understand that actually this is there is a very simple explanations of why it happened, because we trained our data on the spring and summer period of time, and during the spring and summer, the temperature increased with increasing number of months, for example, from March to July, right? And this is why we have some positive correlation. But when we move to fall, and we started to use our model into production in fall, the correlations changed its nature, because with the increasing number of months, the temperature unfortunately decreased. This is autumn or winter. And this is why we have these changes. And this is really nice of us to be able to catch such things, especially when we work with some critical use cases and we have a lot of feature that influences our model significantly. So, okay, let's say that we already able to figure out what exactly is wrong with our data and estimate data quality. There is one more important question I would like to address here, and this is the relevance of our model. Sometimes we start work with our model in production, then some time pass, and we need to figure out whether we need to update our model or not. Is it still relevant, or maybe it's time to conduct some more experiments or retrain our model on new fresh data set. But conducting the bunch of experiments is the pretty time and resources consuming problem, because you need to allocate your data scientist, you need to prepare the data set, and data scientists need to work on this, conduct some experiments again, train models, and this is something that you will spend resources on. And sometimes you have other options to spend your resources on, and maybe it's a better idea to do that tasks. Here, I suggest you to try to check if there is any potential chances to improve the quality of your model in new data. There is unfortunately no guarantees, but at least what we can do, if we can check if our model is still relevant or it need to be updated. And here we have the data and concept drift. This is pretty complex things, and it's hard to actually measure it. But here again, I have pretty pragmatic approach for you, and I will try to help you to at least cover part of the cases with help of some metrics I will suggest later. But first, let's discuss what the concept drift and data drift is, because that's pretty much unusual things. And I would like to start from the concept drift. The concept drift, this is the situation when your target function changes in time. And there is the different kind of drift you might face. I believe you will face one specific kind of concept drift more often on a particular use case, but anyway, let's cover all of them. And first kind of concept drift is the gradual drift. This is the gradual or continuous changing of our target function. For example, there can be a new type of fraud which appeared, and our model haven't seen this type of fraud before, and in this case we need to demonstrate to our model new kind of fraud to make it accountable for it. Or for example, again in manufacturing, we can work on the predictive maintenance problem, and our equipment can wear out, and because of this we might need to demonstrate this to our model to make sure that it can take this fact into account. So this is the examples of the gradual or continuous drift. Another thing is sudden drift. This is something that can happen like out of the blue. For example, these changes in grocery demand and pandemic that we all saw recently, or the unseen change in interest rate in banks. And this is absolutely another type of drift because it's always happens sudden, right? And well, these two gradual and sudden kind of drifts are very different, and the things we can do to help our model are also different, because for gradual drift, we can actually retrain our model on newest data set or create some more robust, more strong features, and this will help our model to live with this gradual drift. But for sudden drift, I would say we actually do not really need monitor for it. I mean, if something sudden happens, it's really pretty impossible to miss it actually, right? So like it happened with pandemic. So probably we will anyway know about it, but there is not much thing we actually can do to help our model. In most cases, it will be again a bunch of experiments, and we will have to rebuild our model like from scratch. And finally, there is some recurrent drift. You might find this concept in the literature. I would say it's not like the real drift. So, and if you have recurrent drift, then probably this is the unseen seasonality or unseen cycles. And well, if this happens, then you just need to make sure that your model can account for it. And there are, again, a lot of methods that could help with it, especially in time series theory. So if you're interested, just not hesitate to look for it. Okay, so this is the concept drift cases where your target function changes. And I would like to move to data drift. This is the situation where your target can stay the same, so your concept does not change, but your data changes. It might happen for different reasons. For example, the outside world is changing, like you had some audience for your application, and then your service grows and you start gaining more clients from different age groups, for example, younger or more senior. And if your model haven't seen them before, it's a good idea to demonstrate this new object to a model to make it more relevant, and especially to make it relevant for this particular group of objects, in this case, new clients. Or the data drift can be a result of our own actions. For example, we could update our marketing campaign, and we can use different acquisition channel, and out of these actions, the amount of new users we get from different acquisition channels might change, and we also need to demonstrate this to our model to make it accountable for it. Okay, so the data drift and concept drift both kind of hard to catch, but I would like to suggest you a pretty pragmatic approach to catch it easily. So first is the feature distributions. For doing this, you need to have the expectations on your distribution. So it's better to plot some distribution from your training phase and compare your feature distribution from production with this training. So you can do it by some statistics, because that's pretty handy, and I like statistical tests. For example, you can use to sample Kolmogorov-Smirnov tests to compare your distributions and see if something changes comparing to the training time, right? Or you can still do the visual analysis. With all my love to statistical tests, sometimes visual analysis helps you to catch some trend even faster. So do not hesitate to look at your features, at least sometimes. For example, here, you plotted the values of feels like temperature during the time, and you can see that it drops. And for example, it starts dropping in like beginning of November, and you could see it easily with help of such plots. And actually, these things can be quantified, right? For example, you can calculate the daily average temperature and see if there is any trend in this metric. Okay, so this is something you also can do and can customize for your problem statement. Okay, this is pretty much all that I wanted to cover. And one last observation I want to share with you is that comprehensive monitoring is really wider than all we discussed today, because for important and complex cases, we need not only know the general performance of our model, but we need to be able to check the performance by different segments, especially if we use our machine learning model in some social services. So we need to make sure that for all the segments of our clients, model actually works. And you need to be able to figure out the low performance segment to make sure you can somehow handle these groups of objects. Model bias and fairness are also very important, especially when, again, we use our machine learning model for some social services, because we need to make sure that our model is unbiased, even if there are some bias in historical data, and we are able to account for it. This is, again, very important, for example, when we use our machine learning to estimate the knowledge of our students, right? Or, for example, for give to the client some social services and prioritize this. This is very important. Outliers is something that you need to pay attention to. And let me bring here an example from credit scoring. If you have a very unusual client came for you and asking for credit, then it's better to identify that this client is unusual and you do not have a lot of such examples in your historical data. And in this case, it's better to process this client manually, right, by some experts, but not give the unreasonable score from your model, because for your model, this is the clear outlier and the score might be irrelevant. And finally, I need to mention explainability, because for some case, this is very important because it helps your client or users generate the trust of you for your system. When user understands why he or she gets these recommendations or predictions, then they generally are more likely will be using your system later. So explainability is something that you might make use of if you have it, okay? So to sum up, we have discussed today quite a lot. We figure out that the setting up the comprehensive monitoring from scratch is the complicated task that needs a lot of resources to complete. So I suggested you to use some step-by-step approach to cover more and more things in each step and start monitor your model earlier. So let's consider the resources you have to build your monitoring and use case complexity and importance. Having all these parameters, we can figure out the steps we need to go through. And if you have a low or medium critical use case and your resources are limited, then I suggest you to create the service health monitoring. This is absolutely recommended, because the service health is something you need to know, right? So it's not an optional thing. And I suggest you start monitoring the model performance. If you get at least a bit more resources, then I suggest you start measuring data integrity, because it will help you to save a lot of time for your data scientists and especially for your data engineering team. If the criticality and importance of your case increases, then I suggest you to look for data drift and concept drift proactively, because you don't want to deal with the critical service in production when it starts degrade and low performance. So and low performance. So this is something I would add together with the increasing of the service importance and complexity. But if your complexity is increasing and you do not have extra resources, this is the very dangerous zone, okay? Because really, if you have critical service into production and you do not have resources to properly monitor it, then it will break one day or another, and you don't want to deal with the consequences of this breakage. And in this case, I really suggest you to maybe reschedule things, or reconsidering doing this project in the first place. At least first get some resources and then start developing the project itself. And this is pretty much all I wanted to share with you today. I hope you enjoyed the talk. At least I enjoyed my time with you. And I just add that if you have some questions or comments, please drop me a line and have a very good day.